So far we have seen the internals of this insertion sorting algorithm, right? And we have also written the pseudocode for it. Now let's go ahead and let's try to write the programmatic implementation of it using Java. For that, I am going to create a new class inside this project, inside this package sorting that we have created earlier. Let me name the class as insertion sort. I'm just going to have the main method as well. I'm just going to click on finish. Now let's write a separate function for implementing the insertion sorting algorithm. So the function declaration will be public static integer array that we have to return in the end after performing the sorting of the values that we have been given. Let's name the function as insertion sort. Okay, now here this function will be taking integer array. I'm going to take that array that we have been given into the ARR variable. Okay, if you remember the pseudocode clearly, we divided the input array that we have got into two types. One is sorted part, the other is unsorted part. So what you can do in the beginning is we are given only one array, right? So what we have to do as part of this implementation, we will have to take the value from the unsorted part and we will have to put it into the appropriate position in the sorted part. For that, since we have to get the value from unsorted part, that means the index will be starting from 1 till n. So to pick that value, I'll be running a loop for int I equal to 1, I less than array dot length, so that we can run the same logic for all the values in the array, and in each and every step I'm going on to the next index. Okay, so what we do inside this for loop is, in the worst case, what can happen, whatever the position that we have assumed, right, that itself might be the correct position for the value we have at that position. So what we will do here is int, let's define, to hold on to that index that we have to put into, I'm going to define a variable called temp index, and I will be assigning it with value of I only. Okay, later on I also want to create this temp index value, and I want to store the value at the index I here. So that is ARR of I. Now the logic of picking up each and every value from the unsorted part is done. Now what we have to do, whatever the value that we have picked, right, we have to put it into the sorted array. How will we do it? We will go left one by one element and we will see if that element is that position is the appropriate one. Otherwise we will try to shift the value onto the right and we will again check for the next element. For that, what we will do, I'll simply run a while loop while this temp index is greater than 0 and the value at this temp index value is less than the value at temp index minus 1. That means we are comparing with the previous index value. Okay, if it is the case, then what we will do, we will simply, that means whatever the value we have at this ith index that we have in the temporary index value is smaller. That means is smaller than the previous value. So what we have to do, ideally the larger value should come here and the smaller value should go here. That's why what we will simply do is the larger value we will move it on to the next index. How will we move it? Array of this temp index we will assign with array of temp index minus 1. Okay, one value we move to the right, but later on we will have to go on to the next element also, just to compare and just to make sure, you know, if it is greater than the temporary index value. That means that we will have to go to the temp index equal to temp index minus 1 position. Okay, by the time we complete this loop, right, we would have moved all the values which are larger than this temp index value to the right by 1 position. So the appropriate position for this temp index value will be inside this temp index variable that we have declared. So what we will do, we will simply be doing array of temp index equal to temp index value. Okay, now in the end we will simply be returning the ARR which has the sorted array. So what we did, in each and every time we are going and picking up the value from the unsorted part, and we are trying to find an appropriate position by comparing the values inside the sorted part, and all the values that needs to be shifted, we are shifting it by one element so that we can insert this temp index value in the appropriate index. Okay, now we have done the implementation. Let's try executing this and validating the results. Let's say I want to sort the array, and that contains the values -20, 1, -3, let's say 100, 9 and 5. Okay, now let me simply call this insertion sort function with the value of a, and let me just store it inside the variable sorted array as we are returning the sorted array in the end. We will simply be iterating over the sorted array, and we'll simply be printing it so that we can validate the results whether the algorithm that we have implemented is sorting the values in the ascending order or not. For that, what we will do, will simply be sorted array of I. Now let's try executing this. Run as Java application. Okay, do you see the output here? -20, 3, 1, 5, 9, 100. Okay, our logic is able to sort the values in the ascending order successfully. Similarly, for descending order, let me just copy this logic and let me just paste it, and just let me align it, and let's name this function as descending order. Okay, so all we have to do, we'll have to change this comparison operation from less than to greater than, so that we will check all the values on the sorted are smaller. Then we will move all the elements by one position to right, and we will put it in the appropriate index position. If we simply call this function, okay, let's just run it. You see 100, 9, 5, 1, -3 and 20. Okay, that is how we can actually implement the insertion sorting algorithm for sorting the values either in ascending order or in the descending order. Okay, thanks for watching. I'll see you in the next one.